Hello everyone, and the topic for discussion is RT security support for inline MACsec. So here's the agenda for today. I'll briefly touch upon, recap on the RT security, and then we'll do the MACsec overview. And what we have proposed is the DPDK MACsec control path APIs. We've introduced two new APIs for SC and SA creates. I'll talk about SC and SA in upcoming slides. And we've introduced a new XFORM for MACsec in RT security session. And then I'll talk about this MACsec and RT flow, how we can configure MACsec flow into to work on to encrypt or decrypt the packet inline during inline processing on the NIC. And then we'll talk about the MACsec data path, and then some device capabilities and stats, and we have some patches. We can have a look at that. So RT security is a library, security lab provides a framework for management and provisioning of security protocol operations offloaded to hardware-based devices. These devices can be a NIC or a crypto PMD, and basically the NIC will be a smart NIC, and it can operate. It can do crypto operations while doing the packet processing from the Ethernet. So it provides a generic APIs for create and free the security sessions to protocol full protocol offload or the crypto operation on the NIC or the crypto device. Basically, this framework is currently supporting ipsec, PDCP, and DOCSIS protocols. As of now, we are introducing the new protocol called MACsec. So MACsec is defined by IEEE as 802.1ae standard, and it allows authorized systems that attach to a LAN. It maintains confidentiality of transmitted data at layer 2, similar to what ipsec does for layer 3. It takes measures for the packets which are transmitted or modified by unauthorized devices or users. It will basically drop them, and it also facilitates secure communication between organizations using the same LAN. It will be useful for people who are using same LAN and basically in some co-working spaces which can have multiple customers which are mutually suspicious to each other, and it can provide secure communication on that end. It can isolate DOS attacks also. Now the packet layout for MACsec is like Ethernet frame. When it comes, the source address, MAC address, and source and destination MAC addresses, ether type, and payload. When this is encrypted using MACsec, new ether type is added, and it is defined as 88E5, and a security tag is added, and the payload may be encrypted or it may be plain as well, depending on the configuration. And it will add an ICB for sure. This ICB may be 8 or 16 bytes, and the sec tag will be optionally 8 bytes or 16 bytes. The sec tag fields are basically these, and these are like PCI, AN, short length, packet number, and SCI input. This SCI secure channel identifier is optional, and it may or may not be used. It depends on the TCI field SC. If this bit is set, then SCI is valid. Otherwise, SCI is not there. The other fields in TCI is this V is version number. It is explicitly set to 0. And ES is the end station bit. And this shows that the SCI is not valid. It is for end station. This SCB is single code copy broadcast, which is for EPON cases, and E is for encrypted payload, and C means that the payload has been changed basically due to encryption, and AN is a 2-bit field with values 0 to 3 to identify which SA which SA is used for encrypting this packet. I'll talk about this later as well. So this is a diagram from 802.1ae standard to specify the MACsec operations. The user data, when it is up for MACsec protection, it will take basically the AN field. It identifies which SA key to use, and it will also use the SCI and packet number to define the sec tag, and based on the parameters, it will do a secure data. It will generate a secure data. It may be encrypted or just authenticated, and if it is, it will also generate ICV for specifying the authenticated data. When this packet is received at the other end, it will again choose the SA key based on the SCI and the AN values, and it will check the packet number, and it can also do anti-replay checks based on the values which are already set for the window size. And once the packet is validated and the sec tag is valid, and it will show up, it will give the user data, plain user data, and the packet is received back to the application. MACsec has some architecture objects like the SecY entry or the security entity. There's an instance of the MACsec implementation within a particular node. It participates in only one connectivity association. Connectivity association is a group of secure nodes talking to each other. It may have multiple secure channels. The secure channel is a unidirectional channel from one node to many, and it may be associated to more than one SAS. So SAS is a key keys which will be used for encrypting the payload or the packet. So this is the base. This diagram shows the one to many configuration of various entities. Like many flows can have a same SecY entity, and many SecY entities can have same SC. And SCs can have multiple SAs. Basically, we have AN values from 0 to 3. So that's why we can have 4 SAs with which can be associated to a particular SC. We had in the previous slide, I talked about a SCI field and a AN field. AN field determines which SA to use, and SCI field will determine the secure channel, which secure channel to use. So these all cannot be in case of RT security. We only have one API to create a session. So these all SecY entry or the SC and SA, these all cannot be accommodated in that. So we introduced 2 new APIs, which I'll talk about in the upcoming slides. So this is the control path for DPDK that we have introduced. First, we will introduce a new API for creating a new SA. This will give you the SA identifier, which will be used to create a SC. This SA ID will be, these SAs will be like multiple SAs will be created, and for each of the AN values, SCs can be added in that. So once the SC is created, SC identifier will be returned, and it will be used for creating the session. This session is a RT security session, and we have introduced a new MACsec XCOM to specify all the options that we have for session configuration. So the output of that session would be a RT security session pointer, which will be set as the action field in RT flow creation when the security pattern is found. When the pattern is matched, then the action will be like security, and action.conf will be set as security session. So these are the MACsec APIs that we have introduced. First is SA create, SA destroy for creation of SAs. For SCs, we have SC create and SC destroy, and the RT security session create and session destroy, what we do for ipsec and PDCP. It will be just changed with the MACsec X form in RT security session cons. So here are the parameters for SA configuration, like the direction of the MACsec, whether it is TX or RX. The keys, the key will be basically only for AES GCN, as the MACsec specification only specifies AES GCN as the algorithm for MACsec processing. It can be of 128 or 256 block size, and the length of the key will depend on that. It also has a 96-bit value of salt, which will be used for encrypting the payload. And next is the AN value, which I just talked about. And this SSCI, it is a short secure channel identifier. It will be used for extended packet number cases, similar to what we have, like extended sequence number in case of ipsec. This XPN is the extended packet number, the upper 32 bits of the 64-bit packet number, and this last one, next PN, is the lower 32 bit of the packet number, which is expected to be coming up for the encryption of this of a packet corresponding to this SA. This value may be 0. It depends on the implementation whether it needs that or not. And if it needs that, then this is the first starting packet number that that will be expected. And beyond that, before this packet number, all the packets will be dropped. Now there are some SC parameters. Again, there will be like the direction is there to specify the RX or TX direction. It will be it will help us in getting the SCRX or the SCTX. For RX side, it will be having a set of 4 SAIDs, which will be created by the RT security MACsec SA create, and these will be set here. Next is the SA in use, like it will be used to specify which SA is currently in use, and we can specify like only one SA is currently used, or all 4 SAs can be used. This SC is active or not, this 1-bit identifier is in that. And for TX side, we can also have a facility for rekeying of the SA, and if the key has expired, then we can have a SAID for rekeying also. We can specify it at the initially when we create the SC. It also has a 64-bit value of SCI, which will be used if send SCI is set. Send SCI is part of the MACsec X form, which will be in the next slide. So this is the MACsec X form. Again, the direction and the algorithm. This algorithm can be like AES GCM with 128-bit or 256-bit, or it can be for with XPN 128 or XPN 256. XPN means extended packet numbers. This cipher offset is the start of the encryption, from where the encryption needs to be started for the MACsec. This SCI field, it is to be used for RX flow identification or to set SCI in packet for TX when send SCI is set. This SCID is created by the RT security MACsec SC create in the previous slide that we talked. Now it has some RX-SecY and TX-SecY properties which can be set. What can be what we want replay window size, or we want to validate the frames. It can have multiple options, like which are stated in this hash defines. Whether to drop the packet once the packet is not correct, it will drop the packet, or it will just give an error. It's just given warning and not drop the packet. It will pass through that packet. It will specify that in this validate frame. Next is the ICV include DASA. So it includes, it means that the ICV that is generated, it includes the source MAC address and the destination MAC address on it. Next is the control port enable. Next is preserve sectag or best preserve ICV. This will, when the packet is received, after decryption, what will happen to the sectag and ICV, whether we want that to be removed in the application, or we want that the PEMD or the hardware has removed it. So if we set these bits, the sectag and ICV will be preserved and application can use that. A replay protect is the flag to enable the replay protection, anti-replay protection. For a DHCP, we set the MTU and the sectag offset. Sectag offset depends on the sectag insert mode. It specifies whether it is at the offset is at a fixed offset from the start of the frame, or it is at some relatives offset. It will be used for matching some VLAN tags. Now this protect frames is to enable MACsec protection. It will do encryption and authentication on not. Next is the ICV includes DSA, which I explained in RX side also. And now these all bits will be used to generate the sectag, like sectag version, which will be 0 always, and end station ES bit. This will be used for ES bit. This is for SC bit. This is SCB bit, and encrypt. This bit will be used to, if this bit is set, then in the PCI we set both the C and E bits. Now next is the once the security session is created, we associate that with the flow, and we can create a MACsec flow, and a new flow item has been created to identify the MACsec flows which the user can use. And then user can use a combination of Ethernet, VLAN, or a MACsec flow item as pattern to create new flow rules, and use flow action as RT flow action type security, along with action.conf is set as RT security session that is created for MACsec. Now the flows, this flow is similar to what we did for ipsec, except that the flow can be created for inbound as well as outbound in our MACsec case. But in ipsec, we only set it for one case, that is inbound. For MACsec data path, there is no special handling required for MACsec. For inline NIC, user can use directly its RX burst or TX burst and do RX TX of the packet. No special handling is required for MACsec flows. If there is some error in transmission or reception of the packet, then it will be notified as an error event, which I'll talk about in next slide. For lookaside case, it will be same as that we were using for ipsec. Like I talked in the previous slide, RT flow rule will be created for both RX as well TX. So we do not need to set the packet metadata, which is required for ipsec. Now these are the error notifications that the PMD or the hardware can specify, like when the packet is received, then what is the error in that particular case. So it will do a validation of the sectag, whether it has some bits in the sectag which are not valid, or it will specify using this event subtype. And similarly, it will also notify whether the hard expiry or the soft expiry of the packet number has come or not for receive and transmit. Now there are some these all MACsec functionality cannot be supported by all the PMDs. So we have some capabilities. So the PMD can specify the various capabilities that it can support, and based on that, application can decide whether to do that processing or not. Now, for MACsec Statistics, we have introduced 2 new APIs for SA and SC statistics, and this takes SCID and SAID as inputs to get the MACsec SA stats or the MACsec SC stats. The SecY stats will be we can get it from the RT security session stats get. It is a generic API for all the RT security protocols for similar which we do for ipsec or PDCP or DOCSIS. Now these are the patches we have for the mailing list, and V1 was posted I think 3 weeks back, and so you all can review those patches. The Ethernet implementation will be submitted in next few weeks, and will be giving the implementation for Marvell cnxk platforms to support inline MACsec protocol offload. And a test application in DPDK test will be introducing new option to validate this feature. So that's it. Any questions now? Thank you.
Thank you, Akhil. Any questions at all from our in-house attendees or virtual? If you have any questions, you can also put them in the virtual chat for Akhil. We got a question down here.
I've got just a short question. So does it blend with MAC in MAC encapsulation?
Sorry.
Does it okay? Does it cooperate? Could it be used for Ethernet frames that use MAC in MAC encapsulation? When when Ethernet frame encapsulates other Ethernet frames, because this is like one of the telecom use cases.
Yeah. Yes, it can be used. There is a field for cipher offset, which can be used for giving you the offset from where we need the encryption. So it can do such combinations, and similar. You're talking about MAC in MAC, right? So there can be options for VLAN also. We can incorporate those as well. We can use this cipher offset and the sec tag insert mode. Combination of these can help us in identify where to encrypt and where to start encryption.
Thank you very much. Any other questions for Akhil? Okay. Well, Akhil, we appreciate you taking the time to zoom in and chat with us and talk about MACsec. And yeah, let's give a round of applause for Akhil.
Thank you.
Great talk.